Will come, you will know. And I will also know. Hurry up, get ready with your books. Why you are asking? Monday's class was an extra class, that's all. Otherwise, we always shift. I know where it shows. Hurry up, hurry up, hurry up, don't waste my time. Yeah, you missed about Viraj, would you like to leave the class? I'm still waiting for silence. Not only are you going to be quiet, but I want everybody to be attentive. Are you all ready with your books? Yes, ma'am. I think I had given homework on Monday's class. Solenoid. Diagram. All of you have said yes, yes, we will do it for homework. Solenoid. Not done? I have done, but right now. Right now. Complete it now. Hurry up, hurry up. Diagram of a solenoid. I want a neat label diagram. Viraj, some special instructions should be given. Field lines or the never mind, those of you who have no pencils, we use a pen. And in the school exams, you will obviously be using marks if you keep on doing this. Come on now, use your pen. Raj, what happened? Yeah, completely. Which I have to. How will you draw the magnetic field first without drawing the solenoid? What is the first thing that you have to do? Draw the solenoid first and then draw the magnetic field lines around it. See. So funny. How will you draw a bar magnet and then you will show the magnetic field lines? Without drawing the solenoid, you are drawing the magnetic field lines. Very good. What happens to these two wires? They're hanging in the air. When you're talking about a wire, this wire, you're taking the wire and then you're coiling it, no? Where are they connected? Why is this wire hanging? This is hanging in there. This is also hanging in there. You have taken this wire. From here you have taken the wire. The same wire has to be coiled, no? So connect it. Yeah. How did you do? Show me. There. Is this a method of doing it? Without a solenoid, what are you drawing? Cut it out. Cut it out. Do it with your pen. Yes, ma'am. This is wrong. This is wrong. Meera, you don't know what has to be done and you are checking what he has done, please. See where the magnetic lines are coming from. It should be inside the solenoid, not outside. Mention which pole it is, north pole, south pole, all that. Yeah, that's okay. Okay, finished? That's it. See, we care about coiling part. I have no idea where the wire is leading from. We are taking the wire, see my chapter, we are taking the wire and coiling it like that. So that continuity I should see that. You are doing it this way, no. See the coiling, this is what you are taking up and down. Keep it. Okay, see this is how you will do. Boys, look here. You will take a wire and coil it. Follow? And connect it. This is the basic idea. Have you followed? I have not made so many coils. I don't want to confuse you. You can make 10 coils or whatever it is. 10. But this is the idea. That is, you're going to have your, okay. And once you switch it on, this develops a magnetic field. So first thing is this part of it. Did you get it? Yes. So you should start your diagram using this as a base. These magnetic fields of force should come inside the outside. And another mistake here, look at the board. Another mistake some of you are making is when you're showing the magnetic lines of force, it should not come outside. It should be inside. It should be inside and then it comes out. Got it? Make sure that it is inside. Yeah. Okay, stop your work and wait. This was actually given for homework which you have not done.
But I had done what I got again. Not झूठ बोलता नहीं.
You see the marker? Did you see the marker?
I'm done. I'm done. I'm done.
Okay. Now, right? So we are seeing that when we talk about the solenoid, okay, stop drawing everyone. Put your pen down. Put your pencils and pens down.
Yes.
So when we are talking about a solenoid, remember the first thing that you need to draw is to make the coils. Okay? You are not going to draw these magnetic lines of force. No. First, you are going to take the wire and make those concentric circles. You are going to go the ends that you have to connect it to your cell. Imagine this one. See the one that I've drawn with black. I'm taking a wire. I'm making those coils coming here, and these two ends I'm going to connect it the two ends of the cell. So obviously one part will be positive, the other one is negative, and we know that the current is passing through all the coils. So as it passes through the coils, what happens is it develops a magnetic field. When I'm talking, I want full attention in the class. Have you followed? So there is going to be a magnetic field which is developing. So as we are increasing the number of turns, the strength of the magnetic field also keeps on increasing. That is what we have seen yesterday. Okay? We can also increase the strength of the magnetic field by increasing the number of cells. So instead of taking one, you can take two or three. That means to say you are increasing the current. Greater the current, the greater is the strength of the magnetic field. So solenoid, of course, we have seen the diagram, and we have also seen that the polarity of the solenoid depends upon which terminal you have connected or in which direction is the current passing. Have you followed? So here it is the negative, so this will be the north pole. You also need to show which is the north and the south, because we have already seen that a solenoid behaves like a bar magnet. So from north to south. So the direction is always in this direction. Have you followed? So in your diagram here in the textbook, you have to also show the direction of the north and south, because the magnetic field lines are always from north to south. Okay, be very careful to show the arrows. If you're just drawing something like this, it makes no sense. You will not get any marks, because the polarity is not given in the bar magnet, neither in the direction is also not given. So make sure that the polarity is also given and the direction of the field lines are also given. Then it's going to be a correct one. Did you understand? So now, there's another very easy method to find out what is called as a phase rule. It's not given in your textbook. Okay, what I'm going to tell you now is something that is not given. That is a phase, clock phase rule. Okay, what happens in a clock? Imagine if you're looking at a clock and if it is going in this direction.
Yeah.
What do we say? It is clockwise. And if you are looking at the direction in the opposite direction, that is, you're talking about this direction, this is going to be an anti-clockwise. So this is going to be a clockwise direction. So here, when I say it is, see how I have written. Okay, I've written in it. I want you to notice the tail of this alphabet S. In which direction is it? Clockwise. It is in the clockwise direction. Okay. If the current is in the clockwise direction, that part of it behaves like a south pole. Did you understand? Look at the tail part of the N for north. How is it running? It is running in this direction. If it is going in this direction, that is, it is anti-clockwise, then that part of it will be your north. So what is this? This is a clock phase rule. So just as you're looking at the clock and you can find out clockwise and anti-clockwise, if it is in the clockwise direction, what? We're talking about the direction of the current. Suppose this is a solenoid. Once again, look very carefully. Such things are not told anywhere else. You're taking your wire and you're winding it like this. So how is the current going? It is going in this direction. Correct? So I'm looking at this direction. How is it going? It's anti-clockwise. But if the winding is in this direction, then obviously it is going to be clockwise. So you have to look at this phase, or you have to look at this phase. See how the current is moving, and then you can decide whether it is a south or the north pole. Have you followed? Yes, you will remember. Yeah. Easy? Take it away. So you write down, I've done this, I finished, so you write this over. See the tail part of N. See the tail part of S. So in whatever direction it is moving, if it is moving in a clockwise direction or anti-clockwise direction, that will give you the direction or that will give you the polarity.
This pole was the north pole, right?
Yeah.
So this will be the anti-clock, and from here,
Always from north. First you identify where the north is, it's always the magnetic line support is always going to be from north.
yeah, from north to south. So
Yes.
they are going to here as well, right? So here it is clockwise.
When you look at the face, not you're looking at the flat surface, not that way. I'm asking you to look at this surface.
Like this.
Got it now? Now, pay attention. I'm going to draw a simple electric circuit. What does an electric circuit consist of? It consists of your cell, right? You may have an ammeter, you may have a rheostat, you may have a key, etc., etc. I'm not drawing all those. Just for you to remember what is an electric circuit, basically because it tells us the path of the electric current. Pay attention. Pay attention. So when this is positive and this is negative, the current flows from
Positive to negative.
yes. So it is flowing from the positive terminal to the negative terminal. So this is going to give you the current. Okay, so this is the direction of the conventional current. Okay. But we also know something about the flow of electrons. We know that electricity is due to the flow of electrons. How does the flow of electron take place from which terminal to which terminal? It is in the opposite direction. So the flow of electrons is in the opposite direction. Is that okay? Now remember that whenever we talk about the electrons, it is nothing but the negative charges. What is opposite to that is nothing but a positive charge. Okay? Because now when we are going to be talking about the flow of current, sometimes they may give you, you will come across a word which is alpha particles, or they may also talk in terms of proton. There's nothing as a flow of proton, there's nothing as, okay, the alpha particles. But you have to remember that when we are talking about the positive, it's going to be the opposite of electron. So if the electrons are flowing in this direction, the positive charges will flow in this direction. So when we say it is a positive charge, you should immediately recognize that we are talking about the conventional current. You understand?
Yes.
Okay. So whenever we talk about the conventional current, initially in those days, scientists believed that it was the movement of the positive charge. Okay, and that is why they have given this direction. But we obviously know now that the positive charges are not the ones which is moving, but it is only the free electrons present in the outermost orbit which is capable of bringing about this current. Okay. So the flow of the current or the direction of the flow of the electrons is opposite to the direction of the current. Is that okay? Have you all followed? Okay. So it is not the positive charges which are flowing, though we are saying that it is the conventional current. Yes? How many of you did not understand? Some of you are looking very blank. Okay, answer. Okay, answer. Did you understand this part of it? You have identified this properly, that the current is flowing from the positive to the negative. Okay? You also know that what happens, we are talking now about the flow of charges. What are those charges? Charges are nothing but the electrons. Okay? Electrons are negatively charged. So remember that the flow of electrons is going towards the positive terminal, as simple as that. It is easy for you to remember that way. Okay? So direction of the current and the direction of the electrons are in the opposite direction. Come to this page. Look at your page, the first page of your chapter. Come to page number 195. You get it here? Yes? We see that the needle is deflected. Ready? See there? It means that the electric current through the copper wire has produced a magnetic effect. Thus, we can say that electricity and magnetism are linked to each other. Then, what about the reverse possibility of an electric field of moving magnets? Okay, so scientists at that point they were able to recognize that when you are passing electric current, it produces a magnetic field. They were also able to understand that when you are having a magnetic field which is getting disturbed, that could also produce an electric current. Okay, so that is nothing but your induced current. Okay. Then in this chapter, we will study magnetic fields and such electromagnetic effects. We shall also study about the electromagnets and electric motors and etc. etc. Okay. So this is basically what we are talking about. Is whenever there is a electric current which is moving through a conductor, it produces a magnetic field. How can we make out by which rule is it? What is it that we have studied? It is the right hand thumb rule. What does it tell us? What does the right hand thumb rule tell us? That the direction of the thumb, yes, the direction of the thumb will show the direction of the current. Have you followed? It is the current. So we are going to take this I into consideration. So you are going to hold your pen or pencil or whatever it is, such that the thumb is showing in the direction of the current. Is that okay? Will you remember it? Because sometimes when we do the sums, you will understand that sometimes they may even give you about the positive charges, proton or the alpha particles or something like that. The moment they talk about the positive charges, you should remember that we are talking about I, which is nothing but the current. Clear? Okay. Next. Don't think it is positive. I'm just telling you about the direction. Direction of the current and the direction of the electrons are not in the same direction. It is opposite direction. Okay. Come back again now. Page number 202. Did you see? We are starting with wait. Don't jump. And you're wrong because you're using your right hand. It is force on the current carrying conductor in a magnetic field. Now let's understand one more thing. So this is a new concept that we'll be starting now. And please pay attention. Suppose I have a magnet. Assume that this is a magnet. Obviously, you know it contains the north and the south. And you also have, assume that this is the north, it is equal. So from the north, okay, you are having the magnetic field lines. Which direction? From north to south. Okay. Assume that this is also another magnet. This magnet I have suspended it with a thread. Correct? And I am getting another magnet. What will happen? Will there be a deflection?
If the north poles are meeting.
Yes, if at all this is north and this is also north, then obviously there's going to be a deflection. Okay, it is going to be pushed away. Okay, that means there is a force which is involved. Not only is there a magnetic field, this one also has a magnetic field. Because there is an interaction of the magnetic field of both the cases, you will find that there is a deflection. Okay, but now we are not talking about two magnets. What are we talking about? We are talking about a magnetic effect due to an electric current. Have you followed? Yes? Okay. Now, so far we were talking about a bar magnet. It is the north and the south. We said always the magnetic lines of poles are from north to south. But you have these magnets which come in different shapes. Do you recognize this shape?
Yes.
It's a horseshoe, right? Okay, so this has got an advantage because you have all the poles next to each other. Always remember, it is from north to south. So your magnetic field line is always from north to south. Okay, so in this experiment that we are going to see now, you are having a horseshoe magnet. You have the north and you have the south. In addition to it, you are having an aluminium wire, okay, which is suspended. Are you imagining what I'm saying? Okay, you are having a wire. This is a wire which is connected to a cell, etc. Battery. So when you're passing current through this, what happens is it's developing a magnetic field. So when you have this magnetic field which is kept here, what is here? What is this? This is my horseshoe magnet. And this is north and south. So your magnetic lines, of course, are from the north to the south. And therefore, this wire which is having current will show a deflection. It might either be pushed up or it might be pushed down, depending upon the direction of the current. Okay, so how can we actually make out? Now, what are the three things that are coming into force? So we are having a current, we are having a force, right? And we are also having a direction of the magnetic field. So we are going to use something very, very simple. Are you familiar with FBI? Yes. What is FBI? Investigation. That's right. Okay. So just like you have your CBI, you have got your FBI. So we are going to use your left hand rule. Left hand. Okay. And it is your Fleming left hand. You are going to stretch out your thumb, the first finger and the second finger, such that each one of them is perpendicular to each other. What does it tell us? This is 90 degrees, this is 90 degrees, this and this is also 90 degrees. You all understand what I am saying? Okay. So this is your F, this is your B, and this is your I. F is for thumb, which tells you the force, the direction of the force. Correct? B is showing you the direction of your magnetic field.
Correct.
And I will be the direction of the current.
So B magnetic field.
B because that is B is usually used for finding out the flux of the magnetic field. Okay, so the easy method for us to remember is FBI. So what does F stand for? This is your force. This is your magnetic field. And this is your current. Okay. Remember, it is not only current, but when you are writing it, remember to write it as direction of the current. It is the direction of the magnetic field. It is the direction. So this actually helps us to find out in which direction is the current flowing. Okay. So all that we have to do is to do this. That's all. Rotate your hand in whatever direction. Suppose they are telling you about FBI. Suppose they are saying the I. Current is flowing in a horizontal wire and the current is flowing from east to west. So I know that this is my east. So east to west. I'm just going to move my hand. Did you understand? Suppose they give you that the magnetic field is the north is here. If north is here, obviously it has to come down. See? That is how I'm going to rotate. So by rotating my hand, I will know what is the direction of my force. What is important here? You find that each one of them, F, B as well as I, this is coming out of the board. Look here. Did you understand? X-axis, this is your Y-axis, and this one is like this. Did you get it? Projecting out of the board, right? So X and Y is also 90 degrees. Your X and Z is also 90. Y and Z is also 90 degrees. So force felt by the conductor is going to be maximum when the angle between them is mutually 90 degrees. Have you understood this one? Okay. Now let's read 2 minutes for you to look at the experiment, see what is happening there.
Now to be 12.7.
हेलो स्टूडेंट्स, कोर्स लगाना चाहिए।
Yeah. Actually, we are performing the experiment in the lab. Did you see? This is your horseshoe magnet. Shift, shift, shift. Shift a little bit. This Shh. Can you make up? This is the horseshoe. And you also have a battery eliminator. This is your battery eliminator. What does it tell us? That we are actually not using a cell, but this is your positive, negative you can make out in the next thing. Okay. So this is your stand which is supporting not only the horseshoe magnet, but we are also going to have a small, okay, here we have got a horizontal line there. You can see when I start. So that basically is your wire through which the current is passing.
जिस पर हमने ये सारा सेटअप लगाया हुआ है, इस सेटअप से ही हम डेमोन्स्ट्रेट करेंगे कि किसी करंट यानी वायर में मैग्नेटिक फील्ड अगर लगाया जाता है तो फोर्स लगता है। इस एक्सपेरिमेंटल सेटअप
Just watch now. Can you make out now? That is, can you see this wire here? Can you see that wire? So we are going to pass current through that wire and you see how the deflection is going to come around. If you're not interested, please walk out. Anybody? So that is basically the conductor that he's taking. We are going to shape it in such a way that it fits in. I'll fast forward for some time. Okay, did you see the position? Look at your textbook, you can find that wire and see how it is placed. Okay. Now he's going to switch it on or off. You see the deflection. Did you see that? When you switch it off, it goes back again. And when you switch it on again, see how it is deflected. Why does it deflection? Because there's a magnetic field which has there. Now further we also see, we have changed the terminals now. Okay? Instead of the positive, negative, we have just changed the terminals. Now let's see what is happening when you switch it on. Will it be in the same direction or opposite direction? Opposite. Okay. So you see this will be opposite direction. That's it? क्या कर रहे हो? So basically, that is your FPI. FPI is written it on the fingers for you to understand. Okay, so that is the FPI. We hold this like this. Also, please. I just want you to see the deflection. There. The moment you switch it on, but once again it goes towards the opposite direction. You get the idea? Okay. If you are paying attention, you would have seen.
समझ ही नहीं आ रहा है कहाँ राइट
Can you also sound? Got it? So let's have a look at the experiment. Kashif, will you read the experiment, please? Activity 12.7.
Yes.
Yeah.
Take a small aluminum rod tube about 5 cm. Using two connecting wires, suspend it horizontally from a stand and hold it to the plasma. Place a strong horseshoe magnet in such a way that the rod lies between two poles with the magnet field directed. For this, put the normal of the magnet vertically and the above the aluminum rod. Connect the aluminum rod in series with the battery and key and
Rheostat. What is a rheostat? What does it do? We have completed in the electrical in the previous chapter. What is the rheostat?
Resistivity.
Resistance. You can change the resistance by using the rheostat. Okay, come on.
Oh. What is this, Rajesh?
Actually, rod inside. You will notice that the rod reverse the direction of current and observe the direction of the it is now towards the right. Why does the rod
Okay. Now pay attention. The displacement of the rod suggests that the force is exerted. Are you looking at your text? Everyone? Okay. On the current carrying aluminium rod when it is placed in a magnetic field. It also suggests the direction of force is reversed when the direction of the current through the conductor is reversed. Now, when you are changing not only the direction of the current, but even if you change the direction of the horseshoe magnet, okay, the deflection will be in the opposite direction. Why? Because now this has become north and this is south. If you keep it this way, the deflection is in one direction. If you change the polarity or the direction of the horseshoe magnet, then also the deflection will be in the opposite direction. Okay, so there are two things that you should remember. Points, right? So two things. One is you can change the polarity, that is the positive and negative, and you can also change the direction of the positive and negative. Everybody in your notebook, you are going to write down what is Fleming's left hand rule. Right? See in this paragraph in activity. Okay. Ready?
Yes, ma'am.
Fleming's left hand rule. Statement, definition, whatever. According to this rule, stretch the thumb, forefinger, forefinger, and middle finger of your left hand.
Stretch the
Forefinger, the middle finger. See, it's here. Boys, those of you having your textbook, girls here. Okay. The middle finger of your left hand such that they are mutually perpendicular to each other. Such that they are mutually perpendicular to each other. In the next line, you will write, if the first finger is the forefinger, right? This is the first finger. This is thumb. First finger and the second finger. Okay. So if the first finger points in the direction, points in the direction of the magnetic field, and the second finger in the direction of the current, then the thumb will point. Then the thumb will point in the direction of motion or the force acting on the conductor. force acting on the current. Okay. Did you notice that we have to use it in the same order? Don't change any of this order. What are the two things that we already know? We know the direction of the magnet. We know the direction of the current. We do not know this. Look here, everyone. We do not know the thumb. Okay, what does the thumb indicate?
Force.
The direction of the force. Okay, this is not known. So first you have to write about the magnetic field, write about the current. Only when you know these two, then you will come to know about the direction of the force. Did you see that? Many times children make a mistake, they'll write all the three together. No. Can you understand? Write it in the same order as what is been given. Then, we are continuing with this paragraph here on the top. Raji, continue from there. Last line. Now on that page, previous page. Now change. नीचे से
Now change the direction of the field to vertically downwards by interchanging the two poles of the magnet. It is once again observed that.
Yeah, we have come to this page now. Okay?
Once again observed. The direction of the force acting on the current carrying rod get reversed, which shows that the direction of the force on the conductor depends upon the direction of the current and the direction of the magnetic field. Experiments have showed that the displacement of the rod is larger or the magnitude of the force is the highest when the direction of the current is at right angle to the direction of the magnetic field. In such a condition, we can use a simple rule to find the direction of the force on the conductor.
Okay. Nandit, continue.
In activity 12.7, let me read.
Yes.
We consider the direction of the current and that of the magnetic field perpendicular to each other and found that the force is perpendicular to both of them. The three directions can be illustrated through a simple rule called Fleming's left-hand rule. According to this rule, stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular. If the first finger points in the direction of the magnetic field and the second finger in the direction of current, then the thumb will point in the direction of motion or the force acting on the conductor. Devices that are used that use current carrying conductors are magnetic fields and magnetic fields include electric motor, electric generator, loudspeakers, microphones, and measuring instruments.
Okay. Next question in your notebooks. Mention a few devices. Mention a few devices that make use of electromagnetism. That make use of electromagnetism. Yeah, we have here. Okay, electric motor, loudspeaker, generators, microphones. Mention at least three of them. That make use of electromagnetism or electromagnetism. Yeah, just a minute. Next one. Next question. Hurry up. When is the force? Take down the next one. When is the force experienced by a current carrying conductor? By a current carrying conductor placed in a magnetic field largest. Do you understand what they're talking
Yes. When they are mutually perpendicular.
about? Yes.
My current carrying.
Current carrying conductor when placed in a magnetic field. It has to be largest. So you have force, you've got the magnetic field, you have the current. When is this force the maximum?
When they are mutually
When these, all of them, when these two are mutually perpendicular to each other, then the force experienced will be the maximum. What do you mean, right? When the angle, or you can say when the magnetic direction of the magnetic field and the direction of the current are mutually perpendicular. Come on, right now, everyone.
And the magnetic
field and magnetic
direction.
perpendicular.
The force experience will be the maximum.
Magnetic field and magnetic.
Magnetic field, and what is this? Direction of what? Current. And the direction of current. If these two are mutually perpendicular, then the force experienced will be the maximum, or it will be the largest. Okay. Perpendicular. What does it mean? It should be 90 degrees. Okay. Look at the second question here. In text question. Come to page 204. Hello. We know that it is 2 more minutes. I know that. Even I know. Come to page number 204. Shh. Look at the second question. 204 and look at the second question. In activity 12.7, how do we think the displacement of rod AB will be affected? If the current in rod AB is increased, or if a stronger horseshoe magnet is used, and if the length of rod AB is increased.
Ma'am, shouldn't it be 12.7?
What did I say? 2.7. 12.7.
No, ma'am, the question it is written 13.7. It should have.
It's the- No, because of that chapter which has been given now. Periodic table has to be deleted. So one chapter has to be deleted. So what is the answer? What happens if you are increasing the strength of the magnetic field? Force will be more. See the first one. Okay. What happens if the current is increasing? Force is more. What happens if you use a stronger horseshoe magnet? Force will be more. Okay, force will be more. What is the other way? By increasing the length of your rod. So by these three, instead of telling it in the form of an answer, they've asked you in the form of a question. Did you understand? So what will happen to the force? The force will be more. Take down one last question for today. Hurry up. How can you increase? How can you increase the force on the rod?
How do you increase?
The force on the rod in the above, whatever it is in that experiment. It is related to experiment. Your answer will be first one. Yes, first point will be by increasing the electric current. Yes. Second one will be by increasing the strength of the horseshoe magnet. Your answer should be in the book before the bell rings. Otherwise, you stay.
Now, what is the second one?
No, what's the first one? Don't scribble, write it neatly, otherwise I'm going to tear out the page. So And what was the second point?
Yes, yes.
Ma'am, when the
Ma'am, what was the
length
second
of
point?
baby, first will be
First is
Raising the
correct.
electric
Second
current.
is magnet, strength of the magnet. Increasing the strength of the magnet. Increasing the strength of the magnet.
भैया देखो बस आपका दिल रखने के लिए टी-शर्ट
पेशेंट बोला ना सही बोल रही है अब पट्टी लस्सी पिला दे चलना
Yes. नहीं वो साढ़े पर है
आज लिटरली सब और कल भी लाइक एवरीथिंग कल तो मंडे नहीं कर भाई ये यूनिफॉर्म क्या है?
पहले मैं ऊपर से इतनी बड़ी है कि
अरे ब्रो पहले I was wondering this क्या हो रहा है?
देखो काटते हो ऑर्डर कराना पड़ेगा इतना लंबा है ये
वही ना भाई नहीं चाहिए
पहनना पड़ेगा संडे भी पहन सकते हैं एग्जैक्टली
भाई चार चैप्टर है इस संडे
मैथ is the equation line of probability of midpoint
हाँ और midpoint हाँ सच में
हाँ because अरे वो अंदर का हाँ ओके
अरे इसमें 22 में राशि
ये बताओ अच्छा ठीक है चलिए बाद में बात करते हैं 25 नहीं 30 सॉरी 29 हुआ
जिसको टीचर ने मिला है उसके पास
बाय
है
बाय बाय
इसके बाद
मैं लीडर ऑफिस
नहीं पप्पा ही नहीं मिला नहीं था शुरू में वाला
अरे एसी बंद नहीं होने वाला
तो हम लोग वर्कआउट लगे रहते
जी भाई भाई क्या मस्त है
मेरे को नहीं मिलता
अरे इतना उल्टा कराया इतना लंबा है रात्रि में आज तीनों कटवाने वाले से मैंने ऐसा पहन कर आई हूँ
जितना पीछे
मेरे घर तक आ रही थी
भाई साइज का ऑप्शन नहीं मिला था पीछे क्यों है
अरे कांचरी और इसका शूज स्मॉल तेरा भी स्मॉल है इसका भी अभी स्मॉल था वो काट के लिखा मीडियम टू स्मॉल इसका
अंजलि को नहीं अंजलि नहीं आई है
अंजलि ऐसा करते हैं की बात है प्रांजलि पहन के नहीं आने वाली
नहीं वो वाली मैंने तुझसे पूछी
बोली तो कि आज स्किल पहने के आती फिजिक्स में क्या पहने मम्मी तो फेमस थी अरे मैं तो अगर बाहर निकालूंगी इतना फनी लग रहा है इतना लंबा इधर तक आ रहा है प्लीज ये लंबी है ना इसलिए लंबी क्लास में लोग अच्छा भाई हाई सबके रखे तो अच्छा तेरा कर पाया
नहीं अब तक नहीं करना है
कभी भी आए
कहाँ पीछे से बैठी है अरे एक ही मिला दो मिला ओ यार दो मिले मुझे भी दो
सबको दो मिला सबको
मुझे एक ही मिला
सबको दो मिला
अब एक चीटी कर रहे सुनना
अच्छा हमें भी दो मिलना पड़ेंगे
क्या आई है क्या
ना पहले
ये भाई बेटी है अरे वो बहुत इधर इधर तक है इधर तक है मोहन तेरा हां किधर है सारा चीज है अरे अच्छा वो वीडियो भी बहुत ऐसे करके आता है जल्दी करो ना मैंने भी ऐसे किया मैं अभी कर रही हूं क्या सपोर्ट देखा नंबर है बेटी ये बात ज्यादा रह गया वो ज्यादा ही 100 मिनट लग गए बहुत यूनिक है माइंड नहीं लो उसका बहुत अच्छा है मैं आऊंगी ना पढ़ जाऊंगी समझ जाएगा भाई कॉन्फिडेंस ऑलमोस्ट रेडी है ना इसका है ना बड़ी अच्छी लग रहा है अब आपको बोलो आप छोड़ देंगे होटल में चल
किसको दी होगी टीचर?
देखो दिया देखो एक ही दिया
1 2 3 और किसको दिया? अरे के और वो उठाती है।
पूरी CBSE
आज टी शर्ट मिल रहा है सबको।